This next section, as we look at it, it's actually a perfect continuation of Anna's talk from a couple sessions ago where we looked at foundations of incident response in AWS. Luke even had asked a question and kind of that follow-up, about incident response in a multi-cloud scenario and maybe what that would look like as you're gathering data from a number of different intelligence sources. So in this session, Peter and Ashwin, both from the Microsoft Threat Intelligence Center, if you guys want to jump in here and turn your mics on and prepare for your session, I'll pass it over to you and we can get started here.
Oh,
there we go. Looking good. I can see and hear you okay.
Cool. Okay, let's get this started. Thank you.
All right.
Thank you for giving this opportunity as well and organizing this particular event. So I'm here along with my colleague Pete Bryant to talk about effective monitoring of cross-cloud environments. So before we start, let me give you a rundown of what we are going to cover today. So we'll start with the introduction of what is cross-cloud and is it applicable to everyone. And then we'll start looking at some of the challenges associated with that, starting from collection, normalization, data collection, as well as the data schema and data models. And then in the latter part of the talk, we'll talk about some of the procedural and technical solutions that the security monitoring teams can apply to effectively monitor these cross-cloud environments. Lastly, we'll also mention some of the attack simulation frameworks that you can use to test and validate your detections. Right? So let's get this started. So starting with your introductions, my name is Ashwin Patil. I have been in the security monitoring and incident response field for over 10 years now. I currently work as a senior program manager for Microsoft Threat Intelligence Center, where my work areas are around cloud security, Azure Sentinel, and some of the threat hunting with Jupyter Notebooks, etc. I'll let Pete introduce himself.
Thanks, Ashwin. So I'm Pete. I also work at Mystic in the research and development team there. Again, focused on cloud attacks and primarily on how to detect them and how to help people kind of hunt and respond to them. My background has always been the kind of blue team side of things, so working in SOCs, doing threat hunting and incident response. And whilst obviously working for Microsoft, Azure is kind of like my focus in terms of a cloud. I've worked across multiple cloud providers and still kind of maintain a focus on looking at kind of more than just Azure and Microsoft products.
So let's start talking about what is cross-cloud monitoring. So currently, for a typical organization, you may already be using multiple cloud service provider, such as Azure, AWS, GCP. Even if you are not using a single cloud provider, you maybe have some uses of SaaS apps, such as Zoom, or you may also have some of the combination of hybrid infrastructures, such as on-premises plus cloud. So monitoring of all these different cloud environments can be considered as a cross-cloud environments. So all of these infrastructures comes with different security boundaries and different auditing capabilities. So monitoring for these environments brings certain challenges that we are going to cover in today's talk. Right? So let's start talking about some of the unique cloud challenges, starting with the cloud migrations. So if you have been in this cloud migration process, they are typically very messy. Even if you are very big and mature organizations, you'll be ahead of most of the issues, but not all. So the cloud migrations are not very smooth. And during this migration, security monitoring is always an afterthought, right? So the another thing is that we want to highlight here is every part of the business can sign up for SaaS apps nowadays, right? So this basically widens your security monitoring coverage, and you have to take those into consideration while strategizing your security monitoring mechanisms, right? Lastly, Nowadays, your developers also can sign up for trial accounts, personal accounts to experiment some of the production workloads without the approval of central IT or security teams. Now, these shadow IT brings certain challenges while monitoring these environments, right? So let's start out talking about some of the challenges one by one. So let's start talking about the collection. Now, typically you may be collecting raw logs, or you may also be collecting just the alerts from this cloud service provider. So you may be collecting something. So the first thing that we need to consider here is the unpredictability of the log sizes, right? So in the cloud services world, it's very difficult to predict the log size as you used to do in your on-premises world. So you may not get a fair estimation of what your log size can be and how much budget that you need to allocate it for, right? The second thing is you may be getting charged for same type of data twice, right? So examples can be AWS CloudTrail or even Microsoft's Defender for Endpoint. You may already be having that solution in place and monitoring certain logs, but then when you want to bring that log to a central log provider, so you may be getting charged twice for the same amount of data for correlation purposes, right? The last thing that we want to highlight here is most of the cloud services logs are basically API based, which API formats and API specification gets changed once in a while. That may change your log collection strategy as well as also affect the final logs getting collected. Right. Now let's move to the normalization part. Now, normalization is not new, right? When you're collecting logs from diverse data sources, you may not have standard data structures across these data sources, right? So even within the same cloud provider, you may have a different services which may be using different acronyms for certain common entities, right? So for example, for usernames, your one service may be calling different fields and the another service may be calling different fields. So all of these issues gets affected directly when you start writing detections and those things, right? The second thing worth highlighting here is like the log format, right? So if you have seen the typical cloud data logs, AWS CloudTrail or even the Azure sign-in logs or Azure activity logs, you will notice certain fields have these JSON property bags with some complex data structure inside it, right? So accessing certain elements within that JSON blobs is not very straightforward unless you are very proficient with the query language, right? So when you start writing the detections for these scenarios, this will make either your queries more complicated and all those things. So I'll hand over Pete to continue talking about certain other issues.
Thanks, Ashwin. So gaps in monitoring have always kind of been a problem for security teams, but these things kind of get magnified in a cloud environment. The more boundaries you have and the more duplication of service you have, the more chance of these gaps coming in. If we think about something like identity, previously, if you were a purely on-prem environment, or if you were just purely in one cloud provider, you might have a single identity platform to monitor. But let's say you're in a hybrid environment, you've now got your on-prem AD, you've got Azure AD, and you've got AAD Connect in the middle. So you've kind of tripled the amount of identity monitoring you have to do just by going to that one provider. Multiply that out for all the other providers you're using and any access brokers, and you have lots of opportunities for gaps to come in there. The other thing that you find is that the speed of the cloud leaves gaps in monitoring. So new services that come to cloud providers all the time quite often find that logging is lagging behind the feature set. We see this quite commonly even with Azure services. They'll go out into a public preview, but actually the features are all there, it works great, but the logging that's being provided into the audit logs is kind of a bit of an afterthought and often lacks some of the detail that you might want or you might need to enable your detection capabilities. So just because you're collecting the logs from a cloud service doesn't mean that you don't have gaps in your visibility and your monitoring. The other challenge that we have in terms of monitoring that Ashwin alluded to earlier is that it's now much easier to sign up for cloud services, whether that be your SaaS apps or whether it just be trialing things within a major cloud provider. Like if you look at the sales technique of most cloud providers, it is give free accounts to devs and let them play with it. Well, that leads to production services appearing there, and before you know it, kind of stuff that you need to be monitoring is gone to a cloud provider you don't know about. And you can no longer go around and say, oh, let's unplug the server and see who shouts. That's how we find out who owns it, because the server is now in someone else's data center on the other side of the world. So the opportunities to have gaps in your monitoring are just multiplied by moving to the cloud, and then multiplied again for each and every cloud provider that you add into your portfolio. If you hit the next slide for me, please, Ashwin. Thanks. So attacks are another thing that pose a challenge in the cloud for defenders. So attacks still follow the same basic pattern that you would previously expect either on-prem or again in a single cloud environment, even when they're hitting a cross-cloud environment. But what does change is the techniques differ and the scope differs. So you might treat your various SaaS providers or cloud providers as silos for a monitoring purpose. You might even silo out cloud and on-prem. But an attacker doesn't care about that. They have one big attack surface that they're going to go after. And this causes all sorts of challenges in terms of monitoring. The other thing that's different is whilst the principles are the same, the techniques differ. If you look at like MITRE's obviously got its cloud matrix with a lot of cloud specific techniques. And they're kind of constantly evolving and changing. New services come into a cloud environment, an attacker will exploit them very quickly. Even if you're not using them as an organization, it doesn't mean an attacker's not going to think about using them. So your attack surface often in the cloud is more than just the services you're actually running. It's anything else an attacker could potentially spin up in there and use to pivot into your environment. So kind of an example of this is late last year, we were working on the SolarWinds response. And one of the things the attackers did was adding new credentials to service principals in Azure. And those service principals then had the privileges to access the data they want. So a classic kind of privilege escalation technique. But this idea of adding new credentials was not one that we'd commonly seen before, because it's not one that's really widely used in a legitimate circumstance. It is sometimes, but it's not kind of an everyday thing. But obviously the attackers don't care about that. So they kind of quickly latched onto that and used that to kind of great effect in multiple places. So it's often the attackers that are driving defenders generally. But again, that just only increases when you get to a cloud and a multi-cloud environment. Next slide again, please, Ashwin. So we've just told you about how terrible it is trying to monitor a multi-cloud environment. It's not all that bad. There are some good solutions you can put in place. And there are actually some benefits of being in a cross-cloud environment and monitoring that you can leverage. So we do have some good news as well. Next slide again, thanks. So in terms of collection, we talked earlier about how collection is hard in a multi-cloud environment. And that's true. Centralizing all your data into one place is a tricky challenge. But there is an advantage that cloud brings us that we can leverage really well in a multi-cloud environment. And that is the accessibility of data. Rather than having to reach out to hosts that are, say, nested in multiple layers of firewalls and access controls, most cloud services expose logs via a public interface or a API on the internet. That makes accessing that data much easier. Similarly, most cloud services offer data with some storage. It's rare that you'll get like a streaming API with logs. You often get a, say, 30-day window of logs that you can access. That's certainly the case for things like Office 365, say. So to tackle the challenge of collection, you can become much more agile in the way you do it, rather than necessarily collecting everything into the central SIM system as you might have done before. You can focus on collecting key data, things like alerts that you need to triage. And again, most cloud providers have great security tools built into them, things like guard duty that you can just leverage the output of. But also you'll kind of got common logs across every platform. So if you are using, say, AAD for your identity across multiple cloud platforms, or if you're using a cloud access broker, you can collect those logs centrally and use them as a kind of pivot point. But then when you need data from these other services, you don't necessarily have to have it in the pool. You can just go out and pull what you need at the time you need it from the stores that they have available. And a really good way of doing this is using something like Jupyter Notebooks. So it's something we use heavily internally, and they provide a really easy and flexible way of accessing different types of data. So as a security analyst, you can triage the alert that you have, and then rather than having to kind of query a big central data store, you can go and pull the required bits of data you need for your investigation from the various API endpoints into your notebook, do your analysis, and then just save that. You don't have to move all of those logs and deal with the hassle, the cost, and the engineering of that. So that's, I think, one of the big advantages of the cloud that people need to embrace is the agility and the open access to the data that you might not have had before. And again, the more cloud environments you start monitoring, the more value this agility has. And the more you can save yourself effort in terms of trying to collect these. Okay, next one, please, Ashwin. Great, thank you. So one of the other challenges Ashwin talked about was normalization. And again, this is much more challenging in the cloud than it previously has been, and again gets much more challenging as you go cross-cloud. Like we had that example of Azure logs versus AWS logs, and just the field showing who did what to what, vastly different in their layout, their schema, but also the structure within them. So building a common data model is key to this. Understanding where data is in certain data types, understanding how they map between them, and then doing the data engineering to get them into a common format is key. The good news is you don't have to do it all yourself from scratch. There's a bunch of good data models out there. We heard yesterday about things like Cloud Query, which can help. OSM has a really good data model. Splunk's data model is also very good. So you don't have to come up with this from scratch. There are ones you can adopt, but you're going to need to modify them for your cross-cloud environment. So one example that I wanted to show is something I did last year was looking at threat detection across a attack kill chain that leveraged Teams, Zoom, and GitHub. And kind of to do anything here, I needed to track a user persona through those services. But before I could do that, I had to map out how these users appear in the logs of each of these sources, which fields they mapped into, how I unpack the different data. So for example, in GitHub data, the username is kind of nested in a JSON blob, so you have to extract that first. And then you need to understand that whilst they're all using, say, an email address for the identity, they're all formatted slightly differently. Like some might be capitalized, some might be lowercase. So you've got to kind of take this into account when doing your pivots and doing the formatting. And so you've got to think about all of that before you can really get into an effective set of detections and hunting. If you don't, you'll find kind of exponentially as you start adding in more cloud services, it becomes harder and harder to create detections and effectively and quickly do your hunting. So investing in a common data model is probably one of the best investments you can make as a cross-cloud monitoring team. Thanks. And yeah, Ashwin's going to take us through the rest of our solution set.
Thank you, Pete. So let's continue talking about the common data model. So this is a perfect segue. So let's take an example of common IOC hunt that analyst gets on a day-to-day basis. So without the common, like if you have a common data model, doing this IOC hunt across variety of data sources is very easy, since all you have to do is basically look for that single column which will have that particular entity associated with that. If you do not have that common data model, you will be basically writing those complex queries every time, and then that may lead to some error prone, and then it may not detect certain activities as well, right? The another thing is like you should like while writing these cross cloud detections, you should identify what are the commonalities between the clouds for your detection purposes. So some of the things that some of the example things that you can do is basically track your user identities across these cloud data sources, right? So the first screenshot example here, it shows basically detecting a failed Azure AD logons, but then successfully followed by a logon to AWS console, right? So as you know that attackers will not limit to a certain cloud. Once it compromises the identity, it will definitely pivot to multiple other environments where the user is present, right? So in such cases, when you're collecting logs from these different cloud providers, it makes total sense to basically have these cross-cloud detections, specifically monitoring for those pivotal activity, right? The last thing that is worth highlighting here is like when you're collecting logs from these diverse data sources, be mindful about the log latencies. Since you are collecting logs from these different data providers, you may have certain log latencies, right? So make sure that your detection logic is robust enough to take that log latency into consideration. Otherwise, the log correlations across these data sources may not work after all. Right? There are certain disadvantages as well while writing the detections. If you have written detections for one cloud provider, it may not work for other cloud provider, since the log detail and depth in one cloud will be different in another, right? So you may not be able to apply the same logic on the other cloud provider, right? Also, so you should be find certain strength and weakness of each data sources, and then leverage accordingly when you're writing a detections, right? The understanding what data is available within each data source is actually a key and successful to detect these cross-cloud attacks and monitoring for these various data sources. So lastly, if you have written all of these detections, you should definitely invest some time in basically testing and validating these detections. One of the ways that you could do is basically simulating certain attacker techniques, and then see like if the generated telemetry triggers those pre-written your detections, right? So fortunately, in the cloud world, it's much easier to stand up a lab infrastructures and also destroy within a single click, since most of the cloud providers provide these automation platforms ready-made. In the case of ARM templates or AWS CloudFormation or Terraform templates, and then you can basically leverage that to write certain simulations, right? So few of the projects that we have highlighted here is the Azure Sentinel-to-Go, Splunk's Attack Range, or F-Secure's Leonidas. So these are some of the projects that you can use as a starting point to write certain simulation, which will basically help you in testing and validating those detections, right? Even if you do not want to basically invest in standing up your own lab infrastructures, you can take a look at the project model, which is basically a project that has a pre-compiled data set available, which you can readily ingest in your SIEM, and then basically test and validate those detections. So you don't have to basically go through all these hassle of standing the lab infrastructures. You can look for these the ready-made data sets available to test and to test and validate your detections. So I'll hand over to Pete to wrap up the session.
Thanks, Ashwin. So kind of what are our key takeaways? The first is that everyone should be doing cross-cloud monitoring. If you're just monitoring AWS or if you're just monitoring Azure, you're going to be missing something. And you need to make sure that you're joined up with teams that are monitoring those other cloud services. And you need to be building relationships with the rest of your organization so you can find out what other cloud services they're using and enable that monitoring. And again, you've got to do that relationship building a lot more proactively than maybe you have in the past, because you don't have the same level of control that you used to. And there will be other cloud services out there, I guarantee it. The other thing you need to do is think of your multiple cloud services as just one attack surface. Again, threat modeling against all your clouds together rather than kind of siloing them out is going to be really useful for a defender. Then look for the commonalities between your clouds. So quite often this is things like identity. Every cloud service needs an identity provider to kind of handle access. So identity is a really good common plane between them. But see if you can identify other commonalities. So things like the Azure Activity Log and CloudTrail. They're different, but analogous. So you can start building your detection and monitoring on those commonalities. And then look at the strengths and weaknesses of different clouds. Different clouds will give you different levels of data, different signals. You can use those in different ways. Don't set one set of detections and try and apply it to every cloud. You can benefit by tailoring to their strengths. A good example of this is with, say, Zoom and Teams. Zoom has a really great logging about kind of meeting events, who's joined, who's left, whereas Teams, doesn't have that. So don't build your detection to your weakest service. Customize them to those strengths. Create those custom detections for Zoom meeting events where you've got those logs. And finally, adopt a growth mindset. It's a bit cheesy, but you need to always be learning. Don't just focus on learning as you go. Try and take a proactive approach and look at what services are new into these cloud providers, not just which ones you're using, but which ones are just being added that attackers could exploit. And again, being a conference like this is a great start, but you need to kind of make sure you're building time into your security operations for people to be able to learn about this stuff, play around with those simulation tools we talked about to discover attacks, and just kind of keep on top of this kind of rapid and ever-expanding growth of cloud services out there. And with that, we want to say thank you very much for everyone for listening. Thanks for the invite to come speak here. We'll obviously be around for Q&A in the Slack afterwards. And also, we talked about quite a few external projects during our talk. So we've got, at the end of our slide deck, we've got a resources page with links to all of them. So you don't have to kind of remember the names. They are in there if you want to reference them in future.
Excellent. I was just about to say we were throwing lots of links out there in the Slack workspace. So that reference slide will be a perfect follow-up for some of the questions I'm seeing going on in there. I love the slide on the simulation tools. That's really cool from a kind of a tabletop exercise perspective and making sure that these things are working. There was a question in Slack. I'll throw it out to either of you, whoever wants to tackle it. And the question's revolving around, data modeling, which probably is one of the biggest challenges that you're going to face here as you kind of build this up with all these different data sources. Did you find any common information models or schemas that you felt got you most of the way there to avoid reinventing the wheel in any of these different log sources?
I mean, it's a good question. I'm not sure if there's one that gets you most of the way there even, but there are ones that have a very good start. So the ones that I've seen that I think are really good are Splunk's Common Data Model and OSM project, which is expanding all the time. So I would kind of strongly recommend those. I don't know if Ashwin has other suggestions or would disagree with me on those two.
No, I think, yeah, the normalization is basically a journey. So definitely you will come across certain things where you'll have to either expand your existing schema and all those things. So those two things that Pete mentioned are definitely a good starting point.
I think the other thing with modeling to think about is don't try and create a model that fits all of your logs perfectly. There's not going to be one model. Like, take it step by step. Maybe look at network-based events and kind of create a common model for your different logs that contain that. Then move on to something else. And you could try and join them all together later. But if you try and create a monolithic schema for every event type, you're just not going to succeed.
Right. You'll be working on it forever, it seems like.
Yeah.
Yeah. So this just kind of, as you were talking through this, data normalization, we talk a lot about, security and writing code and how a lot of folks in this space are realizing that it's important to understand, how to at least, maybe pick up some of those scripting languages and things like that. How important do you think scripting or being able to write code, maybe such as Python, is to succeeding in this space in order to normalize data and get it put into the right models? Do you think it's a key skill set that you need, or are there other ways to tackle that?
I think we would probably both say that it's a big skill to have. We're both Python devs, and we do quite a lot in Python. And I think when I talked earlier about the agility you need in terms of accessing different data sets and kind of calling the APIs to kind of pull the data as you need it, having knowledge, even fairly basic knowledge of using something like Python or a scripting language like PowerShell is going to be really beneficial. And to be honest, it's worth the investment for anyone in security, not just for security, because if you go into any job, if you become a scientist, a physicist in future, Python and data science is really important. If you go and just work as an IT role, PowerShell is going to be kind of key for anyone. So it's not just an investment for security, it's an investment for kind of any career you go into going forward.
Excellent. Let's see, there's another question that popped in here from Luke related to Azure Sentinel. Do you see any drawbacks or implications of, automated response, maybe due to compatibility issues between logic apps, or, ingesting data across, from GCP or AWS, or any gotchas that you might run into as you try to onboard those other systems?
Yeah, I think I can take a little bit of that. Definitely logic apps are really makes it easy to define these automated workflows, but sometimes you may not find all these connectors inside of Logic's app available. So you have to kind of fall back onto some of the other solutions, such as the Jupyter notebooks that Pete mentioned, or even the Azure functions, or AWS Lambda, or those scenarios, which will basically give you full programmatic capability, so that you can look for different ways to either access that data and then basically define your response mechanisms and all those things. And then there are built-in integration of within the product, which will basically have these things pieced together as a solution as well. So we have recently, Azure Sentinel has recently released a solutions concept. So basically you can pre-package all of those things and then define it as a package.
I think
Excellent.
one other thing to think about with automation that's really important is, even if you do manage to automate a response, that shouldn't be seen as something that you just set up and forget. Like automation, something firing and an automated response is key signal for other events. And it's like blocked AV alerts. You don't just ignore them because it's a sign something else is happening. So even if you are using automation heavily, you still need to make sure you're monitoring why that automation is kicking in the first place.
Yeah, it's a great point. It's we automated it for a reason, right? Well, I think we've reached our even our extra 5-minute buffer that we use. Thanks so much for sticking around and answering questions. A lot of good feedback going on over in the Slack workspace. If you've got a few moments to drop in there and kind of hang out for a minute, that would be excellent. So I think at this point, Frank, I'll go ahead and pass it over to you. We'll give Ashwin and Peter a virtual round of applause. Thank you so much for dropping in.